Good afternoon, everyone. Welcome back to the new normal class of Mathematics 7. I am your teacher, Romel Palado. Before we are going to proceed to our topic, let us first have a sort of review of the past lesson. In the first week, we tackle about the basic ideas of set. In the second week, we tackle about the operations of set. For the third week, we tackle about the integers. Then, for the fourth week, we tackle about the operations of integers. For this week, we will be tackling about the basic operations and their properties. Here's our objectives. At the end of this discussion, you should be able to exhibit a familiarity with the properties of basic operations, define subtraction in terms of addition, perform operations on rational numbers, and illustrate their properties. So, symbols and grouping. So, in algebra, letters or variables such as x and y, z, a, or b are used to represent real numbers. To avoid confusion, using the multiplication symbol x will be avoided. Instead, the product of m and n will be denoted by any of the following. For example, we have just simply write m and n, or m dot n, or just simply write m, then close and open parenthesis n, or the close and open parenthesis of m is the same as multiplied to n. So, you can have any of these four. You have seen grouping symbols such as parentheses, brackets, and braces used in mathematics. So, always remember that the general rule is PEMDAS. Whatever you're going to have, whatever the operations you have, so just always remember the general rule PEMDAS. Example, we have the quantity of 5 plus negative 3 times negative 2. Here's the solution. So, always remember, we have parentheses, exponents. So, parentheses, just we have brackets. Still, 5 plus negative 3. Since they did not share a common sign, just simply subtract, then copy the sign of the bigger number. So, 5 minus 3 is equal to 2. Then, the bigger number is 5. Then, the sign of 5 is positive. So, we have positive 2 times negative 2 is equal to negative 4. For number 2, we have 5 times negative 3 plus negative 2. Here's the solution. So, always remember, if you are going to multiply positive times negative, the product is negative. So, 5 times negative 3 is equal to negative 15, then plus negative 2. So, negative 15 plus negative 2, they share a common sign which is negative. So, just simply add, then copy their common sign. So, 15 plus 2 is equal to 17. Then, they share a common sign which is negative. So, the answer is negative 17. For example, number 3. 5 times the quantity of negative 3 plus negative 2. So, always remember, solve first those numbers inside the bracket. So, negative 3 plus negative 2 is equal to negative 5. Since they share a common sign, which is negative. So, just simply add them. Then, after that, multiply it to 5. So, negative 5 times 5 is equal to negative 25. For the last example, number 4, we have 5 times negative 3 plus 5 times negative 2. Here's the solution. So, always remember that if you are going to multiply positive times negative, the product is always negative. So, 5 times negative 3, we have negative 15. Then, 5 times negative 2 is negative 10. So, just simply add the 2 since they share the common sign. Then, copy their common sign which is negative. So, 15 plus 10 is equal to 25. Then, they share a common sign which is negative. So, the answer is negative 25. Now, let's proceed with the properties of addition. What are the properties? So, let's start with closure property. When real numbers are added, the sum is also a real number. To express this idea, you say that the set of real numbers is closed under addition. We have, for example, negative 2 plus square root of 3 is equal to negative 2 plus square root of 3. So, as you can see in our example, So, and in the definition, when real numbers are added, the sum is also a real number. So whatever you add to a real number, still the answer is real number. That is for the closure property. Let's proceed with commutative property. The order of the addends does not affect the sum. In symbols, if x and y are real numbers, then we can have x plus y is equal to y plus x. For example, we have 7 plus -4 is equal to -4 plus 7. If we solve this one, for the right side, we have -4 plus 7. So since they did not share a common sign, just simply subtract. Then copy the sign of the bigger number, which is positive. So -4 plus 7 is equal to 3. Then on the left side, 7 plus -4, we have still 3. So that is for the commutative property. Now we have associative property. The grouping of the addends does not affect the sum. In symbols, if x and y and z are real numbers, then the quantity of x plus y plus z is equal to the quantity of x plus y plus z. So, here's the example. So, always remember that in associative property, there are three or more numbers involved. Just for the example, the quantity of 7 plus 2 plus -3 is equal to 7 plus the quantity of 2 plus -3. So, let's solve first on the right side. So, 7 plus the quantity of 2 plus -3. Since 2 plus -3, they did not share a common sign, so just simply subtract, then copy the sign of the bigger number, which is negative. So 2 plus -3 is equal to -1. After that, we can add to 7. Since they did not share a common sign, again, subtract. So 7 plus -1, we have 6. On the left side, we have 7 plus 2 plus -3. So 7 plus 2 is equal to 9. So 9 plus -3. So they did not share a common sign. Just simply subtract. Then copy the sign of the bigger number, which is 9. So 9 plus -3 is equal to 6. Another property of addition is zero property. Any number added to zero keeps the same number. In a symbol, if x is any real number, then x plus 0 is equal to x. For example, we have 8 plus 0 is equal to 8. So any number, if you are going to add by 0, so the answer is the number. Next, we have properties of opposites. Every real number has exactly one opposite, and the sum of a number and its opposite is equal to 0. In symbols, if x is any real number, its opposite is -x, and x plus -x is equal to 0. So, in the past week, we tackled about the opposite of integers, so just simply apply the concept of that in our lesson. So for example, we have 12 plus -12 is equal to 0. Since the opposite of 12 is -12. So another example, we have -2. So the opposite of -2 is +2. So their sum is 0. Then we have subtraction expressed in terms of addition. So just like for the set of integers, subtraction of real numbers can be expressed as addition. So, always remember this one. The counterpart of addition is subtraction. The counterpart of multiplication is division. So, if A and B are real numbers, A minus B is equal to A plus -B. Now, properties of multiplication. We have closure property. When real numbers are multiplied, their product is also a real number. The set of real numbers is said to be closed under multiplication. For example, we have -2 times the square root of 3 is equal to -2 square root of 3. So that is for closure property. Whatever you multiply to a real number, the product is still a real number. So we have commutative property of multiplication. The order of the factors does not affect the product. In symbols, x times y is equal to y times x. We have, for example, we have 7 times negative 4 is equal to negative 28. So still, we can also have negative 4 times 7 is still, we have negative 28. Then we have associative property of multiplication. The grouping of the factors does not affect the product. In symbols, x times the quantity of y times z is equal to the quantity of y times x times y times z. For example, we have 2 times the quantity of 3 times 4 is equal to 2 times the quantity of 2 times 3 is times 4. So solve first those number inside the bracket. So 3 times 4 we have 12, times 2 we have 24. On the other hand, 2 times 3 is equal to 6, times 4 is still we can have the same product, which is 24. Another property is property of 1. So, in addition, we have property of 0. In multiplication, we have property of 1. Any number multiplied by 1 gives the same number. In symbols, if x is any real number, x times 1 is equal to x. For example, we have 2 times 1 is equal to 2. So, any number multiplied to 1, the product is the number. 1,000 times 1 is equal to 1,000. 1,000,000 times 1 is still we have 1,000,000. Another property is property of reciprocals. Every non-zero real number has exactly one reciprocal. The product of a number and its reciprocal is equal to 1. In symbols, if x is any non-zero real number, then its reciprocal is 1 over x, and x times 1 over x is equal to 1. For example, the reciprocal of 7 is 1 over 7. The reciprocal of 2/3 is equal to 3 halves. The reciprocal of negative 1/4 is equal to negative 4. We also have distributive property. When working with real numbers, multiplication can be distributed over addition. In symbols, if x, y, and z are real numbers, then the x times the quantity of y plus z is equal to xy plus xz. For example, we have 3 times the quantity of 2 plus 5. We can also have 3 times 2 plus 3 times 5. So, if we are going to solve on the left hand, so 2 plus 5, we have 7. Then if we multiply 7 by 3, that is 21. On the other hand, we have 3 times 2, we have 6, plus 3 times 5. So 3 times 5 is equal to 15. Then if we add 6 and 15, we can have 21. Then we have division expressed in terms of multiplication. As what I've said a while ago, the counterpart of multiplication is division. You learned in the previous discussion that subtraction can be expressed in terms of addition. Similarly, division can be expressed in terms of multiplication. So let's proceed with the absolute value of real numbers. So, the concept of absolute value for integers extends to all real numbers. The absolute value of a real number is the distance of that number from 0 on the number line. In symbols, if x is a real number, then the absolute value of x is denoted by the absolute sign. X is defined as follows. We have if x is positive, if x is equal to 0, that is 0. If x is negative, that is negative x. Note that if x is negative, then negative x is the opposite of x, which must be positive. Hence, just like in the set of integers, the absolute value of a real number can never be negative. It is either equal to 0 or a positive number. So, for example, if we have the absolute value of negative 9.06 is equal to 9.06. Then, always remember that if there is a negative sign before the absolute value, so the answer is negative. So, negative absolute value of 8 over negative 13 is equal to negative 8 over 13. For number 3, we have the absolute value of 12 is still we have 12. Operations in rational numbers. We have addition and subtraction of fractions. You say that a fraction is in lowest terms if its numerator and denominator have no common factors except for 1. So, we have for the example of lowest term, so 4 over 9. Another, we have 10 over 8. So, since 10 over 8, they share the common factor of 2, we can have 5 times 2 times 4 times over 4 times 2 rather. So, we can cancel out 2. So, the remaining will be 5 over 4. So, find the other fraction with 12 as the denominator and is equivalent to the given fraction. So, since we have 3 and 7, so we are going to look for, so since the denominator is given, that is 12, so we are going to multiply 3 by 4, then the same as the numerator. So 7 times 4, that is 28, then 3 times 4, that is 12. If we are going to look for the lowest term of 28 over 12, we can arrive to the number of 7 over 3. So, addition of similar fractions. If A, B, and C are real numbers and C is not equal to 0, then A over C plus B over C is equal to A plus B over C. So, for example, we have 3 over 8 plus 2 over 8 is equal to 3 plus 2 all over 8. So, if we add 3 plus 2, that is 5 over 8. We have addition of dissimilar fractions. So, a while ago, we have similar fractions. When we say similar, they have the same denominator. When we talk about dissimilar fractions, they did not share a common denominator. For example, here are the steps in solving that dissimilar fractions. We have express each fraction as an equivalent fraction with a positive denominator. Second, find the least common multiple or LCM of the denominators, which is also called least common denominator or LCD. Then, after that, express each fraction as an equivalent fraction with LCD as the denominator. The fractions are now similar. Add the similar fractions. So, always remember the 4 steps in solving dissimilar fractions. So, let's apply this one. So, perform the indicated operations. We have negative 5 over 4 plus 7 over 3. Since the LCM of 4 and 3 is 12, you will get negative 4 over 4 plus 7 over 3 is equal to 4 times 3. So, 4 times 3, we have 12. So, negative 5 times 3, we have negative 15. Plus, 3 times 4, still we can have 12. Then, 7 times 4, we have 28. Now, if you can see, they have the same denominator, which is 12. Now, just simply add the numerators, negative 15 plus 28, since they did not share a common sign. So, just simply subtract, then copy the sign of the bigger number, which is 28. So, 28 minus 15, that is 13. So, the answer is 13 over 12. Another example, we have negative 11 over 18 plus 19 over 60. Since the LCM of 18 and 60 is 180, you will get negative 11 over 18 plus 19 over negative 60 is equal to negative 11 over 18 times 10. Then, after that, multiply also negative 19 over 60 times 3. So, negative 11 times 10, that is negative 110. 18 times 10, that is 180. Then, negative 19 times 3, that is negative 57. Then, 60 times 3, we have 180. Then, negative 110 plus negative 57 is equal to negative 167 since they share the common sign, which is negative. So just simply add, then copy their common sign, which is negative. So the answer is negative 167 over 180. Subtraction of fractions. Recall that a subtraction statement can be expressed as an addition statement. Subtracting a fraction a over c is the same as adding the opposite of a over c. For example, subtracting 7 over 8 is the same as adding negative 7 over 8. In subtracting fractions, express the subtraction statement as an addition statement. Then, apply the rules for adding fractions. Example. First, express the subtraction statement as an addition statement, then add the resulting similar fractions. Thus, 5 over 8 minus 7 over 8 is equal to 5 over 8 plus the opposite of 7 over 8, we have negative 7 over 8. Now, they shared a common denominator, so just simply add the numerators 5 plus negative 7. Since they did not share a common sign, just simply subtract, then copy the sign of the bigger number, which is negative. So 5 plus negative 7 is equal to negative 2 over 8. Now, since negative 2 over 8 shares a common factor, which is 2, so 2 divided by 2, that is 1. Then 8 divided by 2, that is 4. So the answer is negative 1/4. Let's proceed with multiplication and division of fractions. To multiply fractions, follow the rules stated in the following. If A, B, C, and D are real numbers such that B and D are not equal to 0, then A over B times C over D is equal to A times C all over B times D. Thus, the product of two fractions is equal to the product of their numerators over the product of their denominators. So, find the product. Reduce the answer to lowest term. So, we have 4 over 30 times 70 over 14. So, here's the solution. So, 4 over 30 times 70 over 14. So, we have 280 over 420. So, just simply multiply the numerators. 4 times 70, that is 280. Then, 30 times 14, that is 420. Now, so let's find their common since we are reducing the answer to lowest term. When we talk about lowest term, so we are looking for its simplest form. So 2 times 140, that is 280. Then if we multiply 3 times 140, we have 420. So their common is 140. Now cancel out 140. So the answer is 2 over 3. An easier solution is obtained by factoring the numerators and denominators, then cancelling all the common factors as shown below. So 4 times 30, 4 over 30 rather, times 70 over 14. So the factor of 4, that is 2 times 2. The factor of 30, that is 3 times 10. Then the factor of 70, that is 7 times 10. The factor of 14, that is 2 times 7. Now, cancel out 2, cancel out 10, as well as 7. So, the remaining number is 2 over 3. So, another example, we have negative 12 over 35 times 10 over 3. Now, so here's the solution. Negative 12 over 35 times 10 over 3. Negative 12 over 35 times 10 over 3 is equal to negative times 12 over 35 times 10 over 3. Now, if we are going to factor out 12, so that is 4 times 3. If we factored out 10, that is 5 times 2. If we factored out 35, that is 7 times 5, then 3. So, since the factor of 3 is 3 times 1, no need to write 1. Now, cancel out those common factors. For example, we have 3. We have 3 for the numerators. We also have 3 for denominators. We have 5 for the numerators. We also have 5 for denominators. So, the remaining number is 4 times 2. That is 8. Then we have all over 7. Since the operation, their sign is negative, so we have negative 8 over 7. So, recall that dividing by a non-zero number, b is the same as multiplying by the reciprocal of b. For example, dividing a number by negative 3 is the same as multiplying the number by negative 1/3. Dividing a number by 24 over 5 is the same as multiplying the number by 5 over 24. Or always remember the reciprocal. Find the quotient and reduce the answer to lowest terms. We have 99 over 25 all over negative 3. So this time, we can have 99 over 25 times the reciprocal of negative 3, which is negative 1/3. Now, we can multiply 99 times 1, that is 99. 25 times 3, that is 25. Now, 99 can be factored out into 11 times 3 times 3, times 1. Then 25 can be factored out into 5 times 5. Then we still have 3. So cancel out 3. Then we have 11 times 3. We have 33. Then copy the denominator, which is 25. So the answer is negative 33 over 25. So let's have a sort of review of our lesson today. We have give the opposite of each real number. What is the opposite of 8? So, okay, very good. That is negative 8. How about 3 over 7? Okay, negative 3 over 7. How about negative square root of 2? Okay, we have square root of 2. Now, give the reciprocal of each real number. What is the reciprocal of 2? That is 1/2. How about negative 1 over 5? That is negative 5. How about 4 over 9? That is 9 over 4. Now, find each absolute value. What is the absolute value of negative 42? That is 42. How about the absolute value of 0.6? So we have 0.6. How about negative 13 over 11? Okay, we have 13 over 11. So since in the absolute value, we talk about the distance, so there is no negative distance. So if you have any queries or clarifications or questions regarding our topic for today, just simply contact me to my cell phone number 0930-680-829, or you may log on to our new LCMS, gaitf.sims.school/LCMS. So God bless everyone, stay safe. So just simply follow the learning path rather than always do the activity for your final output. So, thank you everyone.